Okay, let's say we've got a bin with 5 marbles in it. You're going to reach in and take 2 at random. And let's say you just do it all in one motion. So you reach in here, you grab 2 marbles and pull them out. Yeah, we want to know what is the probability that both of them are blue. So a tree can be drawn for this. We've got 2 possibilities of red, 1 possibility of green, and then 2 possibilities of blue. We want to show all those repetitions. Yeah, and then off of that, we want to say what would happen if we grabbed one more, where the one that we grabbed first would be taken out of the mix. So if it's taken out of the mix, that's going to leave us with only 1 path for getting red, 1 path for getting green, 2 paths for blue. So our number of reds is reduced by 1 for the second pick. Then what you want to do is just go through and do that same thing, taking into account what marble was removed and leaving all the remaining marbles in place. We would have that. If we take the green path, there would now be 2 reds remaining and 2 blues remaining. Alright, that is all possibilities. Now it's a little time consuming to make a tree for a lot of marbles just to find out which outcomes meet the criteria. So our first trail takes us to red and then red. Then we'll have RG, RB, RB, we'll have RR, and so on. And we're listing all the different possibilities that could come up. It is not really the most efficient way, though, because it just takes so long. But what we're looking for is 2 blues in a row. And so how many times does that happen? Right here and right here. So there's only 2 cases where I get blue twice. So my numerator needs to be 2. And then we put it out of the entire sample space, which if you count them up is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so that would be my answer for the probability of both blue. Now there is a faster way that you want to use, if possible, for this. We can come up with the fundamental counting principle, which tells us the number of outcomes by multiplying by the fact that there's 5 ways to pick the first marble. Yeah, 5 ways to pick the first marble, 4 ways to pick the second marble. So that's going to give us our denominator of 20. But we can also multiply the probability of the first pick being blue times the probability of the second being blue, given that the first was blue. Alright, so what would those probabilities be? You've got 2 chances in 5 for getting blue on your first pick. But assuming that blue is picked, then your choices now have been reduced to these, which is only 4, and you've only got now 1 way to pick that blue marble. There's only 1 left, 1 out of 4. We would multiply those probabilities. So that's how we get the 2 out of 20 with a formula rather than counting.